Good morning, Doc. Good morning, everyone. As a continuation on the topic on capacity management, I will be discussing three subtopics. As an outline, these three subtopics are service blueprint, queuing theory, and total quality management. Service is a complex, multi-layered process that involves lots of people and technologies that work together, or don't, as the case may be. And that's where service blueprints come into the picture. Service blueprint is a diagram that visualizes the relationships between different service components such as people, props, and processes that are directly tied to touch points in a specific customer journey. Similar to customer journey maps, blueprints are instrumental in a complex scenario spanning many service-related offerings. A service blueprint corresponds to a specific customer journey and the specific user goals associated to that journey. This journey can vary in scope. Thus, for the same service, you may have multiple blueprints if there are several scenarios that it can accommodate. For example, with a restaurant business, you may have separate service blueprints for the tasks of ordering food for takeout versus dining in the restaurant. Service blueprints should always align to a business goal, such as reducing redundancies, improving the employee experience, or converging processes. Service blueprints give an organization a comprehensive understanding of its service and the underlying resources and processes. Here are some of the benefits of Service Blueprint. It helps businesses discover weaknesses. In the same way, blueprints help identify opportunities for optimization. Blueprinting is most useful when coordinating complex services because it bridges cross-department efforts. And last, failure analysis. Once you can see who is or should be doing what, it's much easier to diagnose what's going wrong. Service blueprints typically contain 5 key elements that illustrate the main components of the service being mapped out. These key elements are physical evidence, customer actions, front stage, backstage, and support process. There are also secondary elements which are arrows, time, and metrics. There are also primary lines which are line of interaction, line of visibility, and line of internal action. Service blueprints take different visual forms, but regardless of visual form and scope, every service blueprint comprises these key and secondary elements. So here's a sample of a standard service blueprint. As mentioned earlier, a service blueprint is a diagram that visualizes the relationships between different service components that are directly tied to the touch points throughout the customer's journey. So here are the 5 key elements. So the evidence, this element includes locations like a physical store or the company website. Next is the customer journey or customer action. So these are steps, choices, activities, and interactions that customer performs while interacting with the service to reach a particular goal. Next is that the front stage actions. So these are actions that occur directly in view of the customer. These actions can be human to human or human to computer action. So, example of human to human actions are the steps and activities that the contact employee who or the person who interacts with the customer performs. Human to computer actions are carried out when the customer interacts with self-service technology. For example, an ATM or a mobile app. Next is the backstage action. So these steps and activities that occur behind the scenes to support on-stage happenings. These actions could be performed by a backstage employee, for example, a cook in the kitchen, or by a front stage employee who does something not visible to the customer. For example, a waiter entering an order into the kitchen display system. And last of the five elements is the support processes. These are internal steps and interactions that support the employees in delivering the service. As mentioned also, there are lines or primary lines, and these are line of interaction. It depicts the direct interaction between the customer and the organization. Next is the line of visibility. It separates all service activities that are visible to the customer from those that are not visible. And the next line is line of internal interaction. It separates contact employees from those who do not directly support interactions with customers or users. So here are some of the examples of standard service blueprint. Here's an example, a service blueprint for finance industry, a sample service blueprint for food industry, and a service blueprint for current and future state. In summary of service blueprints, these are companions to customer journey maps. They help organizations to see the big picture of how a service is implemented by the company and used by the customers. They pinpoint dependencies between employee-facing and customer-facing processes in the same visualization and are instrumental in identifying pain points, optimizing complex interactions, and ultimately saving money for the organization and improving the experience for its customers. So next is queuing theory. Queuing theory is a mathematical study of queuing or waiting in lines and how they may be made to operate more efficiently. Queuing theory is also applied to moving objects or information through a line. For example, an auto manufacturer may look to a queuing theory for guidance on the most efficient way to set up its assembly lines. A transport company such as FedEx or LBC can use queuing theory to determine the most operationally efficient manner of transferring packages from one transport vehicle to another. In the world of business, queuing theory can help a company's executives determine the best way to set up and organize business operations so as to maximize both sales and customer service satisfaction. Using a queuing theory can be an important tool for a business in doing cost analysis. Businesses use information from queuing theory in order to set up their operational functions so as to strike a balance between the cost of servicing customers and the inconvenience to customer caused by having to wait in line. In creating a queuing system, there are four characteristics involved. The first characteristic is arrival process. It is simply how customers arrive. They may come into a queue alone or in groups, and they may arrive at a certain intervals or randomly. Next is behavior. How do customers behave when they are in line? Some might be willing to wait for their place in the queue, others may become impatient and leave. Yet, others may decide to rejoin the queue later, such as when they are put on hold with customer service and decide to call it back in hopes of receiving faster service. Next is service discipline. It refers to the rule by which the next customer is selected. This includes the length of time a customer is serviced, the number of servers available to help the customers, whether customers are served one by one or in batches, and the order in which customers are serviced. And the next characteristic is waiting room. It is the number of customers allowed to wait in the queue may be limited based on the space available. If there are four characteristics in creating a queuing system, there are two mathematics of queuing theory, and these are Kendall's notation and Little's law. Kendall's notation is a shorthand notation that specifies the parameters of a basic queuing model. Kendall's notation is written in the form of A, S, C, B, N, and D, where each of the letters stands for different parameters. The A term describes when customers arrive at the queue, in particular the time between arrivals or inter-arrival times. S is for service time. It describes how long it takes for a customer to be serviced after it leaves the queue. The C term specifies the number of servers in the queuing system. The model assumes that all servers in the system are identical, so they can all be described by the S term above. The B term specifies the total number of items that can be in the system and includes items that are still in the queue and those that are being serviced. The N term specifies the total number of potential customers. For example, the number of customers that could ever enter the queuing system, which may be considered finite or infinite. The D term specifies the service discipline of the queuing system, such as FIFO or first come first serve or last in first out. Next is the Little's Law. It was first proven by mathematician John Little that states that the average number of items in a queue can be calculated by multiplying the average rate at which the items arrive in the system by the average amount of time spent in it. In mathematical notation, this is the Little's Law. So Little's Law assumes that the system is in a steady state. The mathematical variables characterizing the system do not change over time. Although Little's Law only needs 3 inputs, it is quite general and can be applied to many queuing systems, regardless of the types of items in the queue or the way items are processed in the queue. Little's Law can be useful in analyzing how a queue has performed over some time, or to quickly gauge how a queue is currently performing. So these are the following situations or examples of how queuing theory can be applied. It can be applied while waiting in line at a bank or a store, waiting for a customer service representative to answer a call after the call has been placed on hold, waiting for a train to come, waiting for a computer to perform a task or respond, and waiting for an automated car wash to clean a line of cars. As a summary of queuing theory is the study of movement of people, objects, or information through a line. By studying congestion and its causes in a process, is used to help create more efficient and cost-effective services and systems. Queuing theory is often used as an operations management tool that can address staffing, scheduling, and customer service shortfalls. Some queuing is acceptable in business. If there's never a queue, it's a sign of overcapacity. And lastly, queuing theory aims to achieve a balance that is efficient and affordable. The last but not the least subtopic that is assigned to me is Total Quality Management or TQM. TQM is described as a management approach to long-term success through customer satisfaction. In a TQM effort, all members of an organization participate in improving processes, products, services, and the culture in which they work. It is also a method by which management and employees can become involved in the continuous improvement of the production of goods and services. TQM views an organization as a collection of processes. It maintains that organizations must strive to continuously improve these processes by incorporating the knowledge and experience of workers. The simple objective of TQM is do the right things, right the first time, every time. TQM is infinitely variable and adaptable. Although originally applied to manufacturing operations and for a number of years only used in that area, TQM is now becoming recognized as a generic management tool just as applicable in service and public sector organization. So how and when did TQM start? The history of total quality management began initially as a term coined by the Naval Air System Command to describe its Japanese-style management approach to quality improvement, an umbrella methodology for continually improving the quality of all processes. It draws on a knowledge of the principles and practices, such as the behavioral sciences, the analysis of quantitative and non-quantitative data, economics theories, and process analysis. TQM started as early as 1920s and has evolved through the years. And today, TQM is a name for the philosophy of a broad and systematic approach to managing organizational quality. Quality standards such as the ISO 9000 series and the quality award programs such as the Deming Prize and the Malcolm Baldrige National Quality Award specify principles and processes that comprise TQM. And here are some of the benefits if an organization is implementing the TQM. It strengthens competitive position, higher productivity, higher profitability, increased job security, improve employee morale, enhance shareholder and stakeholder value, improved and innovative processes. When planning and implementing a total quality management system or quality management strategy, there is no one solution for every situation or workplace. Each organization is unique in terms of the culture, management practices, and the processes used to create and deliver its products and services. Quality management strategy vary from organization to organization. However, a set of primary elements should be present in some format. And these are the generic strategy model for implementing TQM systems. In implementing TQM in an organization, there are actually 5 strategies or 5 different approaches. And these approaches are first, the TQM element approach. The TQM element approach takes key business processes and or organizational units and uses the tools of TQM to foster improvements. This method was widely used in the early 1980s as companies tried to implement parts of TQM as they learned them. The next is the guru approach. The guru approach uses the teachings and writings of one or more of the leading quality thinkers as a guide against which to determine where the organization has deficiencies. Next is the organization model approach. In this approach, individuals or teams visit organizations that have taken a leadership role in TQM and determine their processes and reasons for success. The next is the Japanese Total Quality Approach. Organizations using the Japanese Total Quality Approach examine the detailed implementation techniques and strategies employed by Deming Prize winning companies and use this experience to develop a long-range master plan for in-house use. And the fifth approach is the award criteria approach. When using this model, an organization uses the criteria of quality award to identify areas for improvement. Under this approach, TQM implementation focuses on meeting specific award criteria. Although some argue that this is not an appropriate use of award criteria, some organizations do use this approach and it can result in improvement. W. Edwards Deming's 14 points for TQM is a set of management practices to help companies increase their quality and productivity. And these are the 14 points for TQM by W. Edwards Demings. And these serves as a guide by companies in implementing TQM strategies. Since we already know that total quality management is a process to ensure that all work aims toward the common goal of improving product quality or service, TQM also enhances the production process or process of delivering service. However, in TQM, the emphasis lies on fact-based decision-making, which uses performance matrices to monitor progress. And here are the 7 fundamental principles of total quality management. First, it is customer focused. Quality management process aims to meet customer requirements and deliver beyond expected levels of product or service. Commitment from the leadership. The leaders at all the levels of hierarchy help to establish a unity of purpose and direction. Next is people engagement. This principle states that all the people in the organization must be competent, empowered, and engaged in delivering value. This also enhances the capability to create value. Next is that TQM is process approach. All the activities should be managed as interrelated processes to create consistent and predictable results. These interrelated activities function as a coherent system. The fifth principle is continuous improvements, and an ongoing focus on improvement is a fundamental principle for the success of an organization. Next is that TQM is evidence-based decision-making. The decisions are based on the insights gained from analyzing and evaluating data. This will help to produce desired results. And the seventh principle is relationship management. Organizations should manage their relationships with interested parties, such as suppliers, very well. This will help to sustain the levels of success achieved. And here are some of the companies who implemented TQM. Ford Motor Company, Philips Semiconductor, SGL Carbon, and I think one of the famous is the Toyota Motor Company. In summary, TQM is mainly concerned with continuous improvement in all work, from high-level strategic planning and decision-making to detailed execution of work elements on the shop floor. TQM encourages participation among shop floor workers and managers. And lastly, total quality management drives customer satisfaction by ensuring that consistent delivery of high-quality product or services is in place. For achieving results beyond customer expectations, an organization needs to implement an effective quality management process. And that's the end of my presentation, and here are my references. Thank you and good morning.